Hello everyone, welcome to the second lecture of the series on AI using Python. In this lecture, we will give a brief introduction to Python and also Google Colab, which is an online editor for Python. Python is basically a high-level programming language like MATLAB, R, etc. Here, by high level, we means that the codes in Python are written in high-level languages that uses words and phrases from English language and is easily understandable by human. In other words, the codes in Python are not written in binary languages or other machine languages, which are considered to be low level. The other features of Python are it is open source, which means that it is free and anyone can use it without any license or subscription. And Python is object oriented, which means that the Python codes are built on objects, which can contain either data or algorithms. So objects can be considered as the basic building blocks of Python codes. And the other features are Python is an interpreted language and it has graphical user interface programming support and it is easy to read, code and debug. Next, we can briefly discuss some of the common terms that we frequently use in Python. The first one is function, and a function in Python is a block of code that performs a specific task. In fact, a function in programming can be considered as an equivalent of the function in mathematics, and the data in programming can be considered as an equivalent of sets in mathematics. Classes can contain variables and functions and are used for structuring the code. Now, a module can be considered as a collection of classes or a collection of functions, or it can be a collection of both classes and functions. Then, a package can be considered as a collection of modules. And finally, a library can be considered as a collection of packages. This is more like a simplified definition, and we can consider a library as a large folder with packages, modules, etc. as subfolders. These are some of the Python libraries for AI, which contains a large number of functions for implementing various AI and ML algorithms. The first one is NumPy or numeric Python, which is a Python library that contains functions for array and matrix operations. SciPy or scientific Python contains functions for various mathematical methods from the areas of optimization, linear algebra, calculus, etc. Then we have Pandas or Python data analysis, which is a library that can be used for pre-processing, analyzing, and manipulating data. And we can have various libraries such as sklearn, Keras, TensorFlow, PyTorch, NLTK, etc. that contains functions for implementing various machine learning and AI algorithms. Next, we can discuss some Python basics with some examples. Here for running Python codes, we are using Google Colab. And for running codes in Colab, we simply need to log into Colab using our Google account. For example, we can just type Colab. Then we can click on this Welcome to Collaboratory. And here we need to log in using our Google account. So we can use our Gmail account for login to Colab. After that, we can create a new notebook, or we can open a notebook which is already saved in Google Drive, or we can upload a notebook from any folder in computer. Here we can go with the new notebook option and we can start coding. So here we can either type the code and run it, and also we can add text where we can add the text which contains notes or questions, all these things. And we can have different options for formatting this text as well. And whenever we want to add a code, we can just give plus code, and whenever we want to add a text, we can just give plus text. Once you made a code, we can save it either in Google Drive or we can directly download it into our computer. These codes can be downloaded in two formats. One is the IPYNB, which is the interactive Python notebook, and the second one is .py, which is the Python format. Now let's come back to our code, and we will start with how to import libraries. And for importing libraries or modules or classes, we can use the import command as shown here. Here we imported the NumPy library and renamed it as NP. This renaming part is optional and it is normally used for simplifying the code. And if we rename numpy as np, then later on if you want to use any function from numpy, we can call it as np.functionName. Similarly, we import pyplot module from matplotlib library as plt. This can be considered as a cell, and for running this cell, we can just click on run. Next, we can see how the different variables and data types are defined in Python. We can assign a value to a variable like this, and after that we can print the variable using the print function, or simply typing x here and run. Now we can define an array in Python using the array function in NumPy, and that function can be called as np.array. Here we can enter the values in the array inside a square bracket separated by comma or a space. Now if we run this, we get a one-dimensional array. And if you want to know the type of the variable x, we can use the type function. And here if we run type of x, we can see that x is an array. And in Python, the array indexing starts from 0, which means that the first element of the array is indexed by 0 and the second element by 1 and so on. For example, if we run x of 0 here, we get 1, which is the first element of this array. Now, if we change this to x of 1, it will give the second element of the array, which is 2 here. Similarly, we can define a two-dimensional array or a matrix like this. Note that here a two-dimensional array is defined as an array of two one-dimensional arrays. And here we can find the length of the array using the len function. And if we run this, we get len of x equal to 2. And we can find the shape of the array using the shape function. And if we run x.shape, we get the shape of the array as 2 by 3, which means the array has 2 rows and 3 columns. And we can find the size of the array using the size function, which gives size of array is 6, which means the array contains 6 elements. Now in this 2D array, the first index will be the row index and the second one will be the column index. So here this colon is corresponding to all rows and the 0 will be the first column. So this will give basically the elements from the first column of this array. So now if we run, we get 1, 4. Similarly, we can select first row all columns, which gives the first row of the array, and we can select second row all columns, which gives the second row of the array, and we can select all rows all columns, which gives the entire array. In general, arrays are used for storing numbers, and for storing text we can use string, and for defining a string we can use an inverter comma or a double inverter comma. Now we can print the string, which gives student A. And in Python, we can use this hashtag symbol for adding comments. Now, a list can be considered as a collection of different data types. So in a list, we can store either numerical values or text data. For example, a list L can be defined like this. And if you run this, we get the output of the list like this, which contains both numerical values and text data. And using the type function, we can see that L is a list. Now, if you want to select the first element of the list, we can run L of 0, which gives L of 0 as student A. Now if we change this to L of 1, we get the second element. And if we change this to L of 2, we get the last element, which is a numerical value. We can also add more data to this list using append function. So if we use L.append and add 0.7, we can include the value 0.7 to this list. So far, we have discussed how to create or define various data types in Python. Next, we briefly discuss how to read existing data or data from other sources. We can read data files in different formats such as Excel, CSV, or we can read image files or audio files, etc. in Python. As an example, we can read an Excel file named carsales.xlsx. And for that, first we need to upload the file in Colab. which can be done using the upload option in this file section. Here, if we go to this upload section, we can select the file from the computer that we want to upload, and we select the car sales file. And after that, we can run this cell, which basically read this Excel file using the read underscore Excel function in the pandas library. And for displaying the contents in this file, we use the head function. By default, it displays the first 5 rows of the file. And if we change this to 10, we can see the first 10 rows of D. And if we change this to length of D, we can see the all rows. Similarly, we can read data from drive as well. And for that, we have to first import and mount the drive. So here we have to give permission to accessing the drive. After that, we can read any Excel file from our drive by simply adding the path here. For getting the path, we can just go to this file section. And here, since we have mounted the drive, so we can see a folder named drive here. We can go to the drive and try to locate the file. So here the file is named car sales. So we can just right click on it and select copy path. After that, we can just paste the path here, which reads the data file from the drive. Similarly, we can read and display image files from your computer or drive. And for that, we can use the display function. And here this ai1.png is a file which is saved in the drive. So we just given the path, and using the display function, we can display the image. Next, we can move into data visualization. Here we are taking 2 columns of the car sales file, which we were named as D. First, we are selecting the column title horsepower, and we are naming it as H. And the second column will be P, which contains the price in thousands. So here we can see that these columns are actually from the data file car sales. So which is price in thousands will be this column, and horsepower will be this column. After that, we can use the axis function from the PLT module for setting up the axis and the labels. And we can plot H versus P using the scatter function in PLT, and which gives the plot of horsepower versus price in thousands. Also, we can generate our own data and plot it. And here we are defining X as the input data, which is defined using the linspace function in the NumPy library. Here this linspace function will create 100 data points between 0 and 10. So that will be our input data. And for this 100 data points, we can find the output Y using this linear relationship, which gives Y is equal to A into X plus B. So Y will be equal to 3 into X value plus 2. And we can plot X versus Y using this scatter plot, which gives the output as this. These are some useful commands for help getting the source code of a function and getting the list of all functions in a library, etc. Next, we briefly discuss about the various loops such as for loop and while loop in Python. And for illustrating for loop, we will be considering the same example of plotting a linear input-output data. And here, the input X consists of 100 equally spaced data points between 0 and 10. For this input, we update the output Y using a for loop. And for that, we initialize the output Y as an array of length 100, where each element is initialized as zeros. Then we define a for loop in which the index I goes from 0 to 100. And we update each element of the array Y or Y of I as A into X of I plus B. Now we can plot X versus Y, which gives the input output plot as shown in this figure. where we get a linear relationship between input and output. Now we can repeat the same example using a while loop. Here this length of x is 100. So in this loop, I will goes from 0 to 99. And for each values of I, we update y of I using a into x of I plus b. And also we increment I until this condition is satisfied. And in for loop and while loop, one important thing to notice is that we have to use some space or indentation here to denote that this line is a part of the while loop. And also we have to use same space for each line that comes within the loop. So this space is used for identifying where this loop ends. We can see that this while loop ends here and this line is not a part of the loop. Now we can plot x versus y, which gives the plot as shown in this figure, which is similar to the one which we have obtained earlier. With that, we comes to the end of this lecture, and thank you.